Hey guys, today we're going to start off by just summarizing some of the key trends and ideas about the periodic table. So, the first key idea is that groups are organized by valence electrons. So, group 1 has 1 valence electron, group 2 has 2 valence electrons, 13 has 3, 14 has 4, 15, 5, 16, 6, 17, 7, and 18, 8. You can tell because valence electrons are the last number in the electron configuration. So the fact that this boron atom ends with a -3 means that it has 3 valence electrons, and it makes sense because it is in group 13. Similarly, gallium, aluminum, these also end in 3 because they're also in group 13. This is important because elements in group 13 all have similar chemical and physical properties because they react similarly because they have 3 valence electrons. Overall, everyone on the periodic table is neutral, which means they have the same number of protons as they have electrons. So if you look at the same boron atom, remember the atomic number is the number of protons. So there are 5 protons on boron, and there's 5 electrons when you add up 2 and 3. So you have 5 protons and 5 electrons. So your 5 pluses are balanced out by 5 negatives. And that works for every element. So sulfur over here has 16 protons because its atomic number is 16. And it also has 16 electrons. But its number of valence electrons are 6 because that's the last number here. So every element, as is on the periodic table, is neutral. So then how do we make ions? Ions are made when you're trying to get to the magical number 8 on the periodic table. All elements want to have their valence electrons end in number 8, except for the starting elements that want to end in 2 because they only have 1 energy level. The first energy level always only wants 2. So as you can see with all the elements here, they always just start off with 2 because that's all that can fit in the first energy level. But if you have 2 energy levels, the second one wants to end in 8, and 3, that one wants to end in 8, and then so on and so forth, still wants to end in 8. So they're all trying to get to the magical number 8. So if you have an element like oxygen here, it has 6 valence electrons. So does sulfur. Sulfur also has 6 valence electrons because it's in group 16. So how many electrons does it want to gain? It wants to gain 2 electrons because it wants to have 8 valence electrons and have a configuration that looks like neon. In the case of sulfur, sulfur wants to have a configuration that looks like argon, 2-8-8, so it also wants 2. If they're in group 16, they will always want just 2 more electrons because they end in 6. If they're in group 17, they have 7. They're 1 away from 8. So they just want 1 more valence electron. If they're in group 15, they end in 5. Notice how they all start with -3 at the top for the oxidation number. That's because they all want 3 more electrons. Whenever you're gaining electrons, like these nonmetals will, they're going to form anions. Anions are negative ions because you're gaining negative electrons. So you have this neutral atom, sulfur, that is going to gain 2 electrons to be 2-8-8, and then it will be a -2 anion. And whenever an element is gaining electrons to become an anion, it's going to get bigger. So anions are bigger than the original atom. This is different than cations. all of your metals like to form cations. They like to lose electrons because it's easier for potassium here to lose 1 electron than it is to gain 7. Because if potassium loses this 1 valence electron, it has 8 in the inner orbital, so that is the number of electrons that it wants, so it will be happy. Similarly, calcium, it's going to lose 2 as opposed to gaining 6 to get to 8, because if it loses 2, then the inner energy level has 8, so it will be happy. So group 1, they all have 1 valence electron. Group 2 all has 2 valence electrons. So you'll notice that all of the group 1 ions will form positive 1 cations because they're all trying to lose just 1 electron. In group 2, they're all trying to lose their 2 valence electrons, so they'll all form plus 2 cations. When an atom loses electrons, it's going to get smaller because it's losing its valence energy level. So cations are positive and they are smaller. And metals are always the ones who are going to form cations. Let's take a second to talk about what it means to be in period 1 versus period 2, 3, 4, 5, 6, 7, so on and so forth. Depending on what period you're in, it determines how many energy levels you have. So period 1 only has 1 energy level. So you can see there's only 1 number written down here for hydrogen. Period 2 has 2 energy levels. You can see there are 2 numbers written down here for lithium and beryllium. Period 3 has 3 numbers written. Period 4 has 4 numbers written. Please keep in mind that periods go across, so from left to right, and groups are the ones that go up and down. And you can tell that because period is written this way to indicate that you read it this way. So period 6 will have 6 energy levels, and period 7, while there aren't 7 numbers written, it's because they just got kind of lazy or they run out of space. And so they didn't write the 2-8. But if they did, they wrote 2-8, it has 7 energy levels. They just didn't write it because it's redundant. But there are 7 energy levels even in period 7 as well. Okay, we're now going to take a second to talk about what the groups are called. So group 1, going up and down here, they are called the alkali metals. Group 2, they are the alkaline earth metals. Over here in group 18, they are called the noble gases. Group 17 are the halogens. And so left of the staircase, you have metals. Metals are on the left side of the periodic table. And right of the staircase, over here, you have nonmetals. So along the staircase, for the most part, they are called metalloids. There are some exceptions, aluminum being one of them. Aluminum is a metal, not a metalloid. So even though it's touching the staircase, it does not count as a metalloid. And that makes sense because you all have seen aluminum in aluminum foil, and it looks like a metal. And it is. Down here, you have the lanthanides and the actinide series. And in the middle of the periodic table, these are your transition metals.